Alright, so let's compare. When we're trying to compare things like 0.15 and 0.41, we need to make sure the decimals are lined up, and then we go from left to right and compare the digits. So 0, 0, no difference. The first time we see a discrepancy, 1, 4, whichever one is bigger in the first one on the left, this guy is the winner. Even though the 5 is bigger, it doesn't matter. This is like comparing 15 to 41. 41's obviously bigger, so we go this way. How about this? 7.9, 7.05. Let's do the same comparison. I'll fill in a 0 here to make it all balanced. So we got 7, 7, that doesn't help. Then we got 9, 0. 9 is bigger than the 0. We circle this guy. Even though this 5 is bigger than the 0, it doesn't matter. 7.9 has 1. And then last, obviously 9 is bigger than 5, so 9.48 is definitely bigger than 5.51. Alright, so we got 0.06 compared to 0.50. Nothing here. And then 0.5, oh, this one wins. Let's do 8.5 compared to 8.93. 8s are the same. 9 is bigger than 1. This guy wins. And then 0.5 versus 0.50. 0.5 versus 0.50. Well, remember, if there's nothing here, we can just always fill it in with a 0. So what's going on? The 0.5s are equal, the 0s are equal. They don't give us any more digits, so it's presumably 0s forever and ever and ever. So what's going on? They're the same, right? And these guys are equal.